Welcome everyone to FlexTech's webinar on transparent displays. It's a promising technological development toward placing information on any surface, much like those futuristic videos we see, but which are seeming more realistic every day. We're pleased to work with NanoMarkets today to bring some insights into this market space. This is Heidi Hoffman, Senior Director of FlexTech Alliance, and I'll be your moderator. First, a few logistical items. All participants are automatically placed on mute for the webinar. Sorry about that. I know there's quite a few of you that would like to talk. But today you're in listen-only mode. We are taking questions. Please place them into the question box shown in the control panel on your screen. We'll try to get to as many as we can. If we don't get to your question, we're happy to still answer it. Let's just work on email after the webinar. You can submit questions anonymously, that's fine, or if you sign them, I will announce your name. The slides and the recording from today's presentation will be available in a few days on our website. And I'll send everyone an email with the location and link when that is available. Let's jump into a few things. I'd like to highlight some of FlexTech's upcoming workshops, tours, and conferences while I have you as a captive audience. For more information on any of these, visit our homepage at flextech.org, and then from the list of events, click on any of them to see agendas, registration options, and any other background information. Excuse me. We're partnering with some great organizations for our programs this year. The first one, in about a month's time, is focused on how to engage end users in flexible and printed electronics. The following week, we have an NBMC-sponsored workshop and tour at GE Research in New York. The theme is Wearable Electronics Technology and Applications in Health and Human Performance. Again, check flextech.org for links to all of these conferences and workshops. In July, we're taking a slightly different approach to manufacturing with the Global Summit for Advanced Manufacturing, or we're calling it GSAM, which will be in San Francisco alongside Semicon West. This event is unique in its focus on innovation in manufacturing, not so much any particular industry, and it's case study based, so there's more storytelling about the successes and challenges in manufacturing. That agenda is coming together, and you'll see a broad range of companies across many different industries and not just electronics. The 2 days of conference and 1 day of tours of some local facilities. Right now we're looking at Flextronics and Applied Materials for one tour, and Budweiser and Berkeley's Nanoscale Laboratories for the second tour. But all of that is subject to change, and check it out at gsam.org. Also during Semicon West, we'll be running our workshop on flexible hybrid electronics for wearable applications. Some of the challenges and solutions surrounding that. That's our traditional one-day format. In Europe, we're co-sponsoring the PE Summit with SEMI. That's in October. Also in October, we're working with the Specialty Graphics Industry Association on the Printed Electronics Symposium at the Las Vegas Convention Center. We'll also be speaking at SID, Graph Expo, the Mechanical Engineering Society, and elsewhere on flexible electronics and their applications. You'll see us all over the place. So the calendar for the next few months is quite full and very focused on educating a wider audience on flexible electronics and the breadth of applications. Look forward to seeing you at some of these upcoming events. As many of you know, FlexTech's mission breaks down into 3 major parts. We evangelize for the flexible and printed electronics sector and its supply chain, which are our primary member companies. We champion R&D funding for next generation research and development. We receive funds from government agencies and use the technical representatives from our member companies to solicit and fund the best proposals for advancing the industry. And thirdly, we provide connections and educations for the industry, primarily for our members, of course, through conferences, workshops, reports, and webinars. Which brings us to the reason we are all online today. Our presenter today is Lawrence Gasman, a principal analyst and co-founder of NanoMarkets. Lawrence is an expert on new materials markets, primarily on the economics and of the advanced materials markets. He's consulted, published, and spoken extensively on these topics for both the private and the financial sectors. He brings a great combination of market insights and updates on the technologies. So as I turn it over to Lawrence, a reminder that to those listening in to place questions on the questions box on your control panel as we go on. We'll get to as many as possible at the end of the formal talk. Oh, and we will be placing the webinar in total on our website in a few days, and we'll send a link to all of you when it's available. So Lawrence, the floor is now yours.
Thank you. And let me see if I can get this into slideshow mode. Yes, I can. So thank you, Heidi. I'm Lawrence Gasman. We're going to talk about transparent displays today, and I titled this talk at the last moment, Transparent Display Markets, Hot and Cool. And the hot, as in hot meaning market hot, revenue generation, and all that good stuff, and the cool, transparent displays are very cool in the popular sense of the term. But the question I'm going to try and answer is whether they're hot enough to turn into a business. But just backtracking for a second, let me do the free ad here, free to me that is, a little bit about my company for those of you who don't know much about it. We've been covering nanomaterials, thin film technology and related areas for almost exactly a decade now. I think we just had our 10th anniversary in January, I think. We focus on providing market forecasts, and our coverage is all the areas I just mentioned. We're based in the US, in Virginia, Central Virginia actually, but we have extensive contacts all over the world. To state the obvious, a lot of the areas that we look at, including the one we're going to discuss today, is clearly very much I was going to say an Asian phenomena. Maybe not an Asian phenomena as much as that's where all the manufacturing goes on. And final little bit of my advertorial, most of what you're going to see today is from a report that we published a few months back called Markets and Opportunities for Transparent Displays 2014 to 2021. If you want more details about that, go onto our website, www.nanomarkets.net. And you can find more information about, and of course, we'd be more than happy to sell it to you. Okay, no more ads. What we're going to talk about today is really three things, and they'll be kind of intertwined in the argument I'm going to put forward in the remainder of the slides. First of all, I want to talk about the market justifications for transparent displays. And my justification for talking about justifications is, the idea of a display that's transparent is essentially kind of exciting for people who are interested in things like that. But what I want to try to show is that there's a real business opportunity out there, that there is real potential demand, that there are real applications. And I'll be coming back to what kind of applications they are and spending a fair amount of time on that. And I see that as a primary way of thinking about this sector rather than the technical issues. And here's why. Transparent displays are usually talked about, or often talked about, I should say, in the same context as flexible displays. Probably because they're at the same phase of development and they emerged at roughly the same time. But in my judgment, apart from the R2R applications, if you're talking about intrinsically flexible displays, it's very difficult to think why anybody would want a flexible display when you look at competitive technologies. Transparent displays, I think, are in a very different place. They really do satisfy a need. The second thing I'm going to talk about is technical issues and their solutions. And these are obviously important, but particularly in a negative sense. As you can see, it's fairly easy to get people worked up about the potential and market potential for transparent displays, but when you take it to the next stage, they're quite difficult to actually create and deploy. And some of the solutions to the problems that we'll talk about in a minute turn out to be rather partial solutions. So what you're left with, in the sense jump forward to the end, is a lot of interesting applications, some major problems about getting to those applications, and partial solutions there. So you're left with a slightly imperfect industry, which is and the situation that's probably going to pertain for quite a long period of time. Finally, I'm going to talk about various companies that are involved in this, and what you're going to see there, which makes this field even more exciting, is in addition to the smaller companies who may or may not succeed in the long term, there are some major companies out there who are pursuing either transparent displays or applications for which transparent displays seem to be highly relevant. Now, I'm going to talk first of all about the applications for transparent displays, and that's going to take up a fair amount of my time this morning. Really, there are three different application sectors, classes. I'm not sure what the right word is, but it's important to think about them in classes. The first one, which I have the slide up for already, is really about mobile displays. And here we see enormous potential, a huge addressable market, but also a lot of risks and uncertainties. I'll talk about this in a minute, but just look at some of the things that are on there. You'll see that they're, a bit iffy, as some people say. The second area I'm going to talk about is the whole area of using transparent displays in retail and promotional. And here the applications, the justification for using transparent displays is a bit more down to earth. But the addressable market is, probably several orders of magnitude smaller, at least in volume terms. And then I'm briefly going to talk about a few very niche areas where transparent displays of a kind have been deployed for actually really quite a long time, but where the potential is somewhat limited. So the bottom line there is there's something of a trade-off between the addressable market and the uncertainties or the risks associated with each of these markets. So let's talk about transparent displays in the mobile area. Honestly, this is probably why we're all talking today. It's where there is a potential to sell quite literally billions of transparent displays, although this isn't really happening yet. And it's sort of the reason why transparent displays have become sort of suddenly important, if you like. And the big number to throw out here is 1.9 billion, and which is the number of cell phones sold every year. You can halve that if you want to talk about the number of smartphones, but it isn't extraordinary, which is probably where transparent displays are going to go into smartphones, but it is an extraordinarily large number. If you're talking about something at a systems level, there aren't many things that sell in the billions. And if you're at the component level and something like a discrete capacitor certainly does sell in the billions, but there aren't many systems. So if you're an ambitious transparent display firm, this is a very attractive market to be in, albeit there's small displays and so on and so forth. But 1.9 billion is a lovely number to throw around if you're looking at addressable markets. The other exciting thing is, you put a transparent display either built in or pop up from a smartphone. Well, so what? The other exciting thing is the development of primarily applications that could be called augmented reality applications that are beginning to take off now after quite a few years of people kind of playing around with them. Some of them are location-based services, location-based applications. Perhaps you're driving along, you point your cell phone at a restaurant, and you can see the restaurant and what it looks like, and it will show you inside. Maybe the menu pops up. Or it might be, there isn't actually an application that does this. You're driving along and over your cell phone GPS system, it's giving you information about where other cars are on the road, how well you're located, that kind of thing. So AR is it. There's a good chance that you need a transparent display because you need to see the real world and at the same time have a display that shows the augmentation. Then there's smart glasses. You know, you probably don't actually where FlexTech Alliance is located. Maybe they do see people walking around with Google glasses, and I know well, last time I was in the Valley I actually did, but here in Central Virginia we don't see that much of it. But here is a potential for something that essentially functions as a transparent display, and some people believe or are guessing or forecasting, projecting that smart glass is the next big thing, and that eventually they'll take over from cell phones as the ubiquitous platform for mobile computing. Now, I am not prepared to go that far. Actually, NanoMarkets in the next few months will bring out a report on smart glasses, actually from the component and material standpoint. But I don't think we're ready to go that far that everybody's going to have that instead of a smartphone anytime. But it is an exciting development, and while there's a lot of hype about it, you shouldn't read into that hype. You know that this is just hype. The counter side to that is, are smart glasses really transparent displays? Do they really need transparent displays? And I'll come back to that in a minute. Some of that is purely definitional, it is semantic, because they do, in a sense, function as does a transparent display. The final thing I really want to mention is that in our judgment, while startup companies can often be very important in some of these newer technologies, it helps to have some large companies behind these technologies, because they are able to create a market buzz that small companies simply don't have the resources to do, and they end up promoting new technologies for everybody, even if that isn't their intention. And in that context, I think it's worth mentioning that in one form or another, LG and Samsung, easily the biggest display companies, are already in the transparent display business, with both prototypes and some limited full-scale offerings. Full-scale, I mean, they're actually offering them to OEMs. Apple has a fairly famous patent now for a pop-up transparent display, which, as far as I know, hasn't actually really happened yet. But you know, people watch Apple for product innovation for obvious reasons, and as I say, they do have this patent, so it's a possible new direction. And I've already mentioned Google Glass. So you're looking at a general area where you've got LG, Samsung, Apple, and Google, and that ain't bad. So, you know, all of this is in the context of transparent displays in mobile applications is a little ephemeral, but there are some good reasons to believe that this is an area worth pursuing. But there are really kind of high risks. One is, you know, there's some of this AR, augmented reality stuff out there now, and it works just fine using the viewfinder on the camera in the in the smartphone. And of course, since there aren't really any, as far as I know, mobile displays yet, I mean mobile phones yet, mobile displays that have that are transparent but none in any large volume smartphones. Many of these AR applications just work either on the regular LCD or OLED display, or they work through the viewfinder, so you sort of get the feeling that you're looking at a transparent display, much as when you look through the display to take a picture. So big question number one, do you really need transparent displays in the sense that we're talking about them here? I already mentioned in passing that smart glasses are, in a sense, transparent displays of themselves, but none of them so far really use transparent displays in terms of an integrated display-like product. What you've got are two separate subsystems, one of which provides information to one of the eyes, and then the other one of which does the looking. There are arguments, health arguments for one thing, that a true transparent display much like you saw Schwarzenegger where in the Terminator 1, I guess they're in all the Terminator movies, that makes more sense in the long term. But as far as I know, the smart glasses firms are not really working that direction. Then, some of these, which you're going to see later in this presentation, some of the prototypes, some of the transparent display products are pretty close to prototypes. They're either actually prototypes, find themselves at trade shows and no other place, or they're produced in very small volumes that are sampling-like. Then there's the question about AR itself, about augmented reality itself. It is a very cool reality. I was one of the speakers at the major augmented reality conference last year and got to see all of these applications at the booth at the exhibition. And it's all pretty cool. But what's really unclear is how well some of this stuff will sell. If you're looking at the software companies, for the most part, they're very small companies. There's a few companies that are larger, but they're mostly into creating software platforms for developers. But if you're looking at the actual applications, it's still very much on the cusp of reality. So if AR is the main driver for mobile transparent displays, and it itself is uncertainty, that uncertainty is clearly transferred to the transparent displays themselves. And finally, and I'm going to talk about this in slightly more detail, there are plenty of basic technical challenges, of which perhaps the most obvious and perhaps in some ways the most serious is the, if you're talking about LCD displays, is the backlighting unit issue. Backlighting units, it's hard to have a transparent backlighting unit using classical LCD and in terms of the lighting itself, LED technology. So that raises all sorts of issues about what to do with the BLU and how to, if you move or get rid of the BLU, where else to put it. Then in terms of, then we're going on to the second area, retail applications. Now actually, to some extent, this has been around for a while. In a way, you can emulate a transparent display without actually having an electronic display. So you'll sometimes see like a, fish tank with shoes in it or something, and then the advertising stuff painted on the display. What you don't get is moving words and pictures. To do that, you really need a genuine transparent display. Now, in a sense, the need for a transparent display in these areas are much more obvious. If you're looking at store windows, and I just hinted at that, you can have something that shows the real product, the actual product, the shoes or the food or the furniture or whatever it is, along with moving high definition, quality marketing material, bringing together something in a way that at least prima facie is likely to impress customers. I've mentioned here, called it novel, visually engaging and advertising concepts, and I think that's kind of the core to this whole market. And then we've got transparent billboards, which is an area that we think has some real potential. One, because it's part of digital signage, which is growing amazingly fast and has been for 5 or 6 years. Kind of interesting as an aside, the whole digital signage business began in Las Vegas as, because it was Las Vegas and is now growing to be a worldwide market. It can bring the engaging advertising concepts I just mentioned, but also has the unique feature that it can be two-sided. So it's much easier for customers, potential customers, I guess to see these billboards. And then there are intelligent vending machines. Not all intelligent vending machines need to have transparent displays, but sometimes you can see the product better or advertise the product better, and that kind of intelligent vending machine, specifically with transparent displays, is beginning to emerge in Asia. And again, I mentioned the importance of large companies being involved in this. There is activity in this space from Intel, from Philips, from LG, and from AUO. So that was sort of a cook's tour for the second of those categories. What I want you to do as a takeaway there is really to think about it in terms of kind of what I said in the mobile area, which we were talking about at the beginning. It's all very iffy. I mean, is AR going to take off? Is it not going to take off? Do people really want it? I haven't talked about this yet, but can we even make displays that are transparent, that work with smartphones, et cetera, et cetera? Here, with the retail applications, we're talking about stuff that sort of exists, not very much of it. The problem, of course, is that the volumes are much, much smaller. You're talking about addressable markets in the hundreds of thousands, most probably possible millions, but certainly not the 1.9 billion. The displays will probably be larger, well, they will be larger, and that's good news if you're in the materials business. This is a modest-sized business that won't take over the world, although, primarily because it's starting from zero, is a business that will probably grow fast. Finally, finally for this segment, I want to look at the applications that are kind of here now. One of them is heads-up displays. I mean, basically the idea that you're looking at an instrument panel or perhaps at the windshield, and information pops up in front of you. This has been available actually in the military and the automobile for really quite a long time. In the military, it's pretty standard on military aircraft, and has been for many years, although the technology has changed. Originally, military applications and automotive applications, I think, used actually a CRT-based technology, but they've moved to LCD projection relatively recently. I think in the military, it's, well, first of all, it's not a huge market. Military markets never are. But it's reasonably mature, with the sense, it's not technologically mature, but it's mature in the sense that the market is reasonably well accounted for, reasonably saturated. In cars, I mean, this has sort of been an on and off affair for a long time. I've forgotten the exact date, but GM was putting heads-up displays into its cars a long time ago, 20 years, something like that. But it's never really taken off as a concept. Automobile companies are always looking for applications that will make their cars more novel, and sometimes they work, sometimes they don't. Around about the same time they were first putting HUDs in cars, they were also putting voice synthesis chips in, which would tell you when you left your seatbelt on, and that was incredibly irritating. Again, HUDs haven't taken off. It's obviously partly a cost issue, but I just don't think they've caught the customer imagination. Perhaps they will. There's clearly a technological issue to be addressed here. Since we're talking about real displays and not just projecting onto the windshield with perhaps a special coating on the windshield, have yet to be incorporated into cars. And finally, there's well, actually, one other thing: automotive. The time frame on automotive is always incredibly long. 3 to 4 years before you get designed into an automobile. Because when you do, you kind of guarantee the market to some extent, so it's attractive from the point of view of display makers. Finally, there are museum displays. You could look at an object through a a transparent display and perhaps in some interactive fashion be provided with all sorts of information while still looking at that display. And here I'm talking about actually putting the information on the showcase itself. You could do something very similar by looking through a cell phone. Let's just look at our applications here. Really, oh, by the way, the bottom application, the one that takes up, that says computing and application really should say computing and mobile applications, but for some reason I couldn't change that and this came from our report. I couldn't change that, but that's what it's supposed to say. And the big takeaway here is really just reinforcing what I've been saying kind of all along, which is that when you look at if you look at the huge addressable market for mobile, if you look at relatively small penetrations, and you really have to look at our report to see how we calculated that. We've got all the calculations and assumptions in the report. But if you look at that, what it sort of says to you, I think, in glowing technicolor, is that the reason for the excitement behind transparent displays is really about computing and mobile applications. All the other stuff are, is icing on the cake. And I actually did the forecast for this, and it sort of doesn't matter what you actually assume the penetration is, or how low or how high, as long as it's something plausible. You're not going to get 100% penetration in 3 years or something. And, given that we're probably all on this call thinking that there's some potential here, it's not going to be 0.5% in 10 years either. But almost no matter what you do, you end up with the real revenue generation coming from that one application. So that's solid if the risks that I indicated don't turn out to be too severe. So let's go into the technical issues. And, the technical problems around transparent displays, there's quite a lot of them. And I think the only reason for not making it the first thing to talk about is there isn't a lot of point in solving them unless there's a potential market for transparent. One of them is obviously, if we're talking about LCD, is obviously getting rid of backlighting units. I mentioned this in passing. So how do you do that? Well, you can basically get rid of the backlighting unit and use ambient light. And there's nothing new about that. I'm looking at my computer display right now, but to the left of me is a rather boring old wired telephone that has an LCD display in it that isn't lit by anything except the lighting in this room, and it kind of works. People have certainly made transparent displays by taking out the BLU, but obviously the effect, it looks a little washed out, and if you're talking about something that you want to be impressive to a mobile phone user, and certainly in retail, that isn't a very attractive way of simply getting rid of the BLU. It saves some money, saves some power, but that may be beside the point in terms of the actual applications. Another one is projection technology, and you essentially have, everything else apart from just getting rid of the BLU is essentially finding some other place to put it. Projection technology is established too, obviously projection TVs, but also, as I mentioned before, that's the basis of HUDs. It becomes more complex and potentially more costly. Waveguide really means that you put the lighting somewhere else and use a waveguide or even a piece of fiber optics to get the light to the display. At least as far as we can determine, although that has some potential, it doesn't seem to have been used very much in practical transparent displays, although it could be in the future in waveguide technology in the context of data communications is very well established, has been for decades, so the technology is out there for someone to do something clever with in the context of displays. I should also mention, although it's a whole different topic, that there's a whole area of transparent electronics that really is a lot bigger than just the transparent displays, and we're going to have to talk, if we're really going to have real transparent displays, about transparent electrodes. Well, that's not much of a problem because there's transparent conductors are pretty standard issue materials, but transparent transistors are a whole new area which has been researched but not widely deployed for many years, a decade or so, I guess, and would probably revolve around using zinc oxide as a semiconductor. And lots and lots and lots of research on that, big literature and everything, but very little. There's certainly use of zinc oxide as a transistor, but not with transparency in mind. Finally, not finally on that list, but I mean, it's the obvious direction to take, is transparent OLEDs. The point being there that you intrinsically get rid of the BLU because OLEDs are emissive, so you don't need any extra light, and that's a good thing. You still need transparent transistors, but I'm kind of leaving that out of this story for the time being. So that is the way that a lot of people are thinking, and not to give the rest of the story away, but we're still at a very early stage with that. We'll see how early in just a minute. Moving on, here it's maybe a little bit of a busy slide, but this is where people are with LCD displays and LCD transparent display panels, and it probably isn't a complete list. A few takeaways from this is who's in it. Samsung and LG, that's a good sign that this is an important area because the big guys are backing it. Second takeaway, which is really reinforcing the point I made just now, is that if you look at the current status, it says available all the way down. So you're talking about stuff you can actually buy. They're all pretty big displays, though, and that's because they're really being aimed at, well, actually mainly the retail and advertising area, the telepresence area to some extent. And if you look down the future potential, you'll see a few ways that some of these big suppliers have thought about using it. And of course, that's, the more these things get used, the more applications people will come up with. Returning to my point about OLEDs, OLEDs are the obvious solution to move away from LCD, and I've heard people talk about transparent displays and they automatically jump to OLEDs, but it's not an entirely easy play there. I mean, for one thing, the metallic cathode needs to be replaced by a transparent conductor. Now that's, that's not basic physics or some sort of, oh my God, it'll take 40 years, like printing a heart or something. But it is a technical challenge at a low level. There's also unsolved problems about the light. There seems to be a problem, or it says so in some of the literature, that there's likely to be light loss, which may or may not make a difference depending on applications. On the other hand, you've actually got intrinsic light in there, which can actually cause some sort of disruption. Nevertheless, you can't dismiss OLEDs because any of these reasons, and again, you've got some interesting companies in there. Samsung, yet again, no big surprise since we're talking about OLEDs, a couple of other companies, and UDC has a presence there because they have their TOLED program, which has other reasons for existing, but is basically a transparent OLED program. So certainly important companies working in that space, but it just doesn't compare to where we are with with LCDs. And if you're talking about transparent displays today, if you want one in your product, if you're talking about something that has to be delivered or designed in the near future, you're going to be looking at LCD first. That will change. Perhaps it'll change very fast. Here's an equivalent slide to the one I showed for LCD. Actually, more companies in there, probably reflecting in some ways the early stage. I mean, and it's even busier than the other one. But and some impressive companies again. LG, Osram, NEC, Philips, Samsung, Toshiba, UDC, BASF is in there somewhere. This is good news, but then when you begin to dig a little deeper, we deliberately put up lighting as well as displays, which of course aren't the same thing, but because we're at an early stage of development, it seemed that they were related enough that not to include lighting, transparent lighting, was to shortchange the whole research program of creating transparent OLEDs. The topic today was displays, and as you see, once you get rid of lighting, you get rid of quite a lot what's on here. So, that may inject slightly more skepticism about, not about OLEDs as transparent displays so much as something that's going to happen tomorrow. And again, finally, on this slide, if you look down the current status, you'll remember on the equivalent side for LCD, it's commercialized, 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 available, available, available. We're really talking about something that hasn't happened yet. Either it's in the process of commercialization or it's available in very low volumes. And here's our projections for OLEDs versus LCD. And it's the same numbers that you saw on the earlier slide in terms of totals, but it's just very difficult to imagine OLEDs, however suitable they are, and lots of people think that's the way transparent displays will ultimately go, but it seems to us, and we've run the numbers a number of different ways, that this is still going to be an LCD play for, we cover 8 years. Who knows what we'll be in 20 years. But that's what the market we think will look like over the next 8 years, folks. So that's something I think to consider when you're looking at the market for transparent displays as a whole. We're sort of coming to the end here. If you looked at the two busy slides I mentioned, I think that there are probably 6 companies that kind of jump out at me as being the places to watch for the big developments in transparent displays over the next few years. Samsung and LG for sure. I mean, Samsung's king of the OLED anyway, and they're looking for new applications for that. And actually, at the bottom, UDC kind of falls into that scope too. LG is the other big display company, AUO. And then there's Google and Apple, which popped up in my talk all the way through, are certainly companies that could exploit this for use in their AR applications or in their increasing involvement with the cell phone business. A few caveats, especially about Apple, really. One is that Apple is very skeptical about OLEDs. There were years of speculation about whether the next iPhone or iPad was going to have OLEDs in it, and that's effectively been quashed for the time being. Who knows how these things will change for a number of reasons that I don't have time to go into yet. So they may well have transparent displays, but there must certainly be LCD ones. And Apple's also important because of its level of interaction. I put Planar up here, which is obviously a smaller company than the other ones on here, because it's been in that business for a long time. It's early entry and established an enviable place in the retail side of transparent displays. So I think company worth looking at. I'd say also there's a sort of runner-up in terms of NeoView Colon, which is one of the very few companies to really have gotten anywhere with mobile OLED transparent displays. I'm sure if all those adjectives are in the right order, but I think you know what I mean, and are delivering them in very small volumes at the moment. So the takeaways of my talk are, hopefully after what I've said, you'll believe that there's a plausible revenue generating market or multiple markets for transparent displays. You know, all of them come with their risks. The ones that aren't all that risky, like HUDs, are relatively mature, or there's real questions over, you know, whether you need them in automobiles or not. I forgot to mention, actually, one reason for putting them in automobiles is to make looking at the instrument panel easier and safer, but on the other hand, having something moving around in front of you on the windshield may not be all that safe either. The technical issues are secondary only in the sense that they don't need to be resolved if there's no market out there, but they're quite difficult. And some of them are kind of nitpicky, like, you know, there should be no problem about replacing a metal electrode with a transparent conducting oxide, but anybody who's actually been actively involved in the manufacturing or the coating side just knows at the factory level, not so much at the design level, but at the factory level, it's just going to be difficult to do stuff like that. Encouraging sign in the names of half a dozen or so major companies with active programs for transparent display, not just R&D programs, but, you know, or rather R&D programs, but the emphasis on the D, and real commercialization. They're in, you know, all over the place, which is encouraging. And if our numbers are right, then we're talking about a $4 billion market in 2021, although, you know, and that's based on, you know, moderate penetration numbers. So that's, well, this is my bio, which you can read on your own or wait till the movie comes out. And this is our contact information. If you want any more information on the report or on our products and services more generally, then please contact us. There's many different numbers. And all that's left time for me to do is to thank you for your time. Thank you very much.
Thank you, Lawrence. Very interesting talk. A lot of detail there, a lot of topics there, and some detail. And most of the questions we've received so far just seem to request a little bit more detail on some of the markets that you talked about, or some of the products that you talked about. So let me just kind of get started here. One question on the market size for digital signage, just to clarify that, I think that you referred to that as in the hundreds of thousands, possibly 1 million. Is that about right? Anything else?
What I was talking about was addressable markets. And the point I was making is that, you know, there are 1.9 billion cell phones sold, and any one of those might have a transparent display put in it, which makes for, I mean, that's a very attractive market to be in, given those numbers. When you look at digital signage, you know, you're talking about sizable signs up there. It's a market where total shipments are a few million every year. They're clearly never going to be billions, because that isn't, you know, I mean, how many digital signs do you see every day? Some percentage of that could be transparent, and the good news there is that these are big displays, and therefore they generate a lot of revenues per unit. So what I was saying is that the moderate penetration could get you into the hundreds of thousands if that took off as a way of doing advertising. And they are big displays, like I said, so that's where that number came from. You know, it's a business that a moderate-sized company could handle. You know, if you're going to get into the transparent mobile displays, that's great as a startup. But the first thing that's going to happen when an OEM comes to you is they're going to say, you know, either you're kidding, or if they're very enthusiastic, they're going to say, when can you deliver the first 5 million? And if you're a startup, that could be a problem. It's just a business that might be better suited to a lot of companies that are out there. So the 100,000 is, or whatever number I said actually, there's a real number. Well, there's our projections are in the report, but the that's the kind of thing that drops out of any reasonable analysis.
Okay, thanks. Okay, jumping over to the augmented reality image formation, depth, and real objects that the AR is supposed to overlay. Developments in addressing that disparity between, what's in front of you on the display and then the depth of it. Have you looked deeply into that? Is that something we should take offline, or is that something you want to chat about right now?
I haven't looked deeply into it, but what I can confirm is that issue and that kind of issue is a really big deal, because I mean, well, there were two things. One is, when I mentioned one of them, when you look at augmented reality, it's really cool. I mean, I think the annual big augmented reality show is about to happen, or just happened, I'm not sure. But going there is a lot of fun. I mean, it's a lot more interesting in a fun, take your kids to than, say, going to a thin film electronics show. But it is a very primitive, no offense, it's a very primitive stage for exactly those kinds of reasons, that it's certainly augmented, because it is, but the reality stuff is questionable. It's very two-dimensional. Does it really add anything that you actually want? Is it more distracting than anything else? You asked specifically about the 3D, well, about the depth of vision, about depth of field of it, but that's a broader issue. I mean, how much does it really augment reality, and how much is it, how much is it a regular display with a little bit of text that pops up? I mean, that's a big question, and in some ways, I'm not even sure I'm the guy to ask. It would be someone who was a consultant on augmented reality, which I'm not. But I mean, whoever asked that is onto something, which I didn't really discuss in depth.
Yeah, and I know there's plenty of, well, at least I know there's two strong human factors research programs looking at what the impact of that is and how it, how it corresponds. So hopefully we'll be hearing more from those folks as there's more products on the market to analyze and to comment on.
Yes.
Yeah. Okay. Let's see, a copy of these slides will be available on, actually the whole webinar is being recorded and will be available on our homepage at flextech.org. So that takes care of that one. Let's see, would you please comment on the transparent integrated circuit? You mentioned that, it's going to be the transistors, transparent transistors are a ways away, but transparent conductives are available. Do you have any other comments, any additional comments on that?
Well, so I stayed away from transparent transistors because it's a bigger topic. It's certainly part of this topic, but people talked about a whole kind of transparent electronics that goes way beyond displays. I mean, we have a report that's kind of aging about transparent electronics, and I think that from transistor point of view, the materials platform has solidified around some kind of zinc oxide, but still a really researchy sort of topic. I mean, again, you may have to take the transistors, off the back. But as far as I know, the only practical switching material for transparent displays is probably zinc oxide. There are probably other oxide semiconductors that can be used, and I did say this, but I'll repeat it. Oxide semiconductors for switching is a big topic all on its own, but they're primarily used in non-transparent applications. The other possibility, of course, is using some kind of organic material, because the organic material could be transparent or semi-transparent. And the problem with that, it might actually maybe in some ways make it easier to make it transparent, but how can I put this now? Is the whole OT-FT thing seems to be only, like half a mile from where it was when I mentioned NanoMarkets is 10 years old. We were writing about that 10 years ago, and it's moved a bit in the right direction, but awfully slowly. So I think that to the extent that you have to have some sort of active matrix behind a display, and it's going to be big and impressive, you're probably going to have to use ZNO or something like that. The chances are that if you want some decent quality display, it's probably going to be projection based. I was at a trade show, gosh, it's 2 years ago now, and I saw some very impressive transparent displays that did all sorts of cool things. You could see the front and the back and everything. Incidentally, the show was in China, which is interesting in itself, that the technology was so advanced. But those really interesting ones that look good all used projection technology. You mentioned transparent conductors, and that's kind of a different story, because we have, in terms of the number of options we have for transparent conductors, there's more of them than you can kind of shake a stick at. So there's plenty of options there. The issue is a smaller one than with transparent transistors, in the sense that you just get to be able to perhaps replace a metal with a transparent conductor, and then you get into all the issues about conductivity and being able to do a direct replacement without having to change your machinery and all that sort of thing, which are tactical rather than strategic or scientific issues. So I do think TFTs, if you really want a high quality transparent display, are an issue. If you really do at the moment, projection is probably going to be the way, because then the switching is somewhere else.
Mm-hmm. Okay, great. Okay, and our last comment, because we're nearly out of time and everybody's got to get to their next hour's meetings, I think there's a good number of us that would like more concept of what these products are really going to look like, especially in the computing and maybe that mobile space, the mobile computing space. What do these products look like? Do we need to just wait and see what designers come up with, or is there, I know you talked about mobile, but even digging down deeper into what exactly do they do?
Well, what they do is what I said, but what they look like is a very good question, Heidi. If you look at the Apple patent that I mentioned briefly at the beginning, what that talks about, and it's getting a bit of an old patent now, so maybe it's been overtaken by events, it's actually a second display. It sort of pops up or slides up on your cell phone. It's funny, when I said that, my cell phone lit up, so it must have been listening to me. But so that's a second display. Now, whether that makes, that's what that would look like, but maybe that no longer makes sense. Maybe you simply have some kind of transparent phone, which would look good would look good from a design thing, and you only have one display. So that's on the mobile phones. I think that when you're talking about retail or signage, that's more defined. It would look like a display case, but instead of, if you think about a display case, it is in a sense a transparent display, but all you can do if you want to add graphics or text is kind of, print them out and stick them on the glass. Here, that glass itself would be changing all the time. You can also have some fairly dramatic and impressive signage that you couldn't do any other way. So what I was thinking about when I was talking about my experience going to the show in China, they had one of the companies there, a Chinese company, had a huge display with some young lady dancing, and it was, first of all, it was a cartoon, so the graphics were limited. This wasn't glowing high definition color of, some dancer or other from television. It was limited in definition and in contrast and all those sort of things. But it was big. It must have been like a 50, 60-inch display. So she was almost life size. And what was really impressive is that, she danced in front of you and you saw her face. When you walked around to the other side of the display, you could see her from behind as well. So these are things that you could do in signage that you really can't do any other way. I mean, I guess you could have signage and then you walk behind it and there's actually a picture of it or some second display that somehow links up, but that's complex, costly, and fundamentally different to what I was talking about. So, I mean, that's the kind of thing that can be achieved. And going right back to what I said at the beginning, I'm a little skeptical about two displays on a cell phone. We'd kind of, in one way, we used to have two displays on the cell phone because it wasn't uncommon to have an LCD display that showed, the smartphone side of things, and then you'd have a little passive matrix OLED display on the other side of the flip with a clock on it or something. So, I mean, you just have to think through that whole design thing. Now, it was an Apple patent, and they're very good at thinking through design stuff, but I think, we don't know for sure what all that stuff's going to look like yet.
All right. Well, very good. We are out of time. I appreciate everyone hanging in here with us, and thanks very much, Lawrence, for the information. And again, you can find more information on flextech.org.